Hi, and welcome to my presentation about predicting long-term collision risk. My name is Jordi Daniëls, and it's getting busy. Maritime traffic is still increasing over the last 20 years by 300%. Still, in the whole world in trade, 90% of all cross-continent trade is carried by sea. And this is bringing some implications or some complications in maritime traffic. One thing is, as it's getting busier, more vessels are traveling, and also larger vessels are traveling across sea. And while that may not be a problem for oceans and seas, it is a problem in coastal areas and ports. Because as that is increasing, the amount of ships and the size of ships, the size of ports is very difficult to also increase at the same rate. And bring into that mixture as well that more sea structures are being built than ever. Here in the Netherlands, we are building massive windmill parks that even narrow the amount of waterway down more, which brings up the quantity in ships and also the density of waterways, which could lead to more complications and collisions, which is one of the problems that we're countering here. Now, I do not have to tell you about the negative effects of collisions, which are terrible, of course, but also potential collisions, so collisions that never occur at all, have a massive negative side effect, whether that is financial, environmental, by the amount of extra CO2 emitted, or just stress of captains and also other personnel involved. So the problem is quite big, and the amount of casualties is big as well. While still the biggest problem of the biggest casualty cause is still the loss of propulsion power, which accounts for 22% of all casualties. Collisions account for 13%, and two others, contact and grounding, account for 17% and 13% respectively. They add up together to 44%, and they all have the same problem. They all have the same problem, which is navigational nature. So problems with the navigation of ships. And that is something that we would like to counter here. And while the amount of casualties is only 13% for collisions, the amount of fatalities is way higher for collisions. Because when collisions do occur, they are very drastic. And that's why we want to do research on this and try to predict them. But there's another problem, a small problem, which is very heavy impact, which is the data. So AI can work in all sorts of ways. We can use inductive method or deductive method. But there's a problem with the data. The scarcity of data is massive. There's just a lack of observations, because while collisions are terrible and they happen quite frequently, in order to do proper machine or deep learning, there's actually not enough data. But we can move from a different way as well. We can make observations, we can recognize patterns, and then make a lot of assumptions which we guard with expert opinions in order to make hypotheses. And that's what I'm going to present right here, and the theory of how to do long-term collision risk. But why should we even use AI? That's a question I get asked so many times, and the key is in the observations and the pattern recognition. AI is just very strong in this. It can understand billions of rows of data, and don't be alarmed, billion rows of data is what a port produces annually, for example, in our systems. And it can recognize patterns in all those billions of rows of data.